Topic A, variables and values. Now, let's start with variables. So I'm afraid I'm going to have to define variables in terms of values, but nonetheless, I'm sure you'll be able to follow. A variable is a reference to a location in the memory which stores a value. So it's like a label in a program that points to a memory location which then has something. So that something is a value, and variables can store these values. So you can almost interchangeably say, this variable is a string. Basically, it means that this variable is a reference to a place in a memory that calls a string when I say it. So a variable is a string, that's the disambiguation. So variables can be strings, which are basically a collection of characters, text variables. Variables can be integers, which are whole numbers, positive and negative. Variables can be floating point numbers or floating point values, which are decimal point numbers with high precision. Variables can be booleans. Booleans are either true or false. And so a boolean is generally used to control program logic. Now, variables can also be different data structures. So like more complex data structures like lists. These lists may contain all of these strings, floating point numbers, booleans. They can be dictionaries or sets. So next we got values, of which there are two varieties. We got numeric values and string values. Now, the first type of numeric value is an integer, which is a whole positive or negative number. Here's the most basic integer expression in Python, 7. That's an integer expression. 7 is an integer. Python understands it. You put this in the interactive shell and it just prints out 7. Here's another example. This integer expression basically adds 4 different integers. Add up to 24. This is a multiplication, 5 times 5. This is a subtraction. Next we have floating point numbers. Now, floating point numbers are real numbers with a decimal point dividing the integer from the fractional part, like 10.5. 10 wholes, that's the kind of integer portion, the decimal point, and the 5 is like kind of 5 out of 10. That's the decimal point. Floating point expression in Python, 7.1. So Python, anything with a dot, Python is going to recognize as a floating point. And here are some operations and expressions that evaluate. So 5.24 plus 2.0, that's another floating point. And that is another one. Now, be careful with floating points. Sometimes you can have, instead of 25.5, it'll write 25.50000000001. This is generally not an issue, but perhaps if you're printing out values, you may have to use floating points with the round function. So the integers in particular have a large list of operations that you can do with them. You can apply some of these to both floating points and strings, but all of them apply to integers. So you can add integers with a plus sign, subtract integers with a minus sign, multiply them with a star sign, divide them with the dash. You can calculate the remainder of a division with the modulo. You can perform operations where you can get 2 to the power of 5. You can use the exponent, which is the star, and you can divide without remainder. So a double dash division. So next we have string values. So string values are essentially text that we place in quotes. You can have a string that's basically made out of all alphabetic characters, but you can also have a string made out of numbers entirely. That would be a numeric string. So strings can contain letters and symbols, like I said. Three Musketeers is a string. First Order is a string, even though they have different characteristics. For instance, this one here has a numeric sort of character in it, and this one doesn't. So let's have a look at some examples. So you remember that table of operations? You can use, for example, the plus. You can add a string to a string. You can multiply a string. Right here, monkeys times 5 is monkeys, 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 monkeys. But you couldn't subtract one. So with no further ado, what I'm going to do now is get into PyCharm and play around with strings, integers, and floating points, as well as these operations here so that you can see them in code in the interactive shell. In this video, we are going to demonstrate the following operations in the interactive shell. We're going to start with addition, then subtraction, multiplication, division, modulus, exponent, and floor division. Now, I'm also going to do this not just with values, I am going to assign variables. So we're going to see basically how we can do all of these operations on both variables and values. So addition, the straightforward one, if you said 9 plus 8, that would make 17. And if you said A equals to 5, B equals to 10, A plus B, that would be 15. Subtraction, B minus A would be 5. But you can also say 5 times B minus 6 times A, and that would be 20, because 50 minus 30 is 20. So we have in one line done multiplication as well as subtraction. Now, let's do division so we can continue the theme using the times. So if A is 5, so maybe we can say A times 10 divided by B. That is 50 divided by 10, which is 5.0. Now this is the first time we've got a floating point result. And we are almost always going to get a floating point result when we do division. No matter, even if you divide 2 by 1, you're not going to get 2, you're going to get 2.0. So in that vein, we can do a variable C, and that could be equal to B, or maybe we can make it fractional, right? 3 times A divided by B, something like that, right? So that would be 1.5. 3 times A divided by B. And if you say C, that's 1.5. So let's then have a look at the modulus, which is basically getting the remainder of a division. So like if I say B percentage A, that is 10 divided by 5, which is 2. There is no remainder for that. So the remainder is 0. But if we divide B percentage C, well, the remainder is 1.0. Because if you divide 10 divided by 1.5, you're going to get 6. 6 times 1.5 is 9, and then there's a remainder of 1, which is 1.0. Which kind of shows you that you can use the modulo with basically floating point values. Next, we have the exponent. And so if you have A, which is 5, to the power of 2, we should get 25. But you could put it to any power, to the power of 92, and then it's going to be a huge number. So, last but not least, we have floor division. That is division without a remainder. So you kind of ignore the remainder and round it. So let's say you have 100 divided by, let's divide it by C. You're going to get 66.667. Now, 100 floor division by C, you're going to get 66.0. So basically it kind of removes, it doesn't round it, or you could say it always rounds down, but basically it ignores the remainder. So there you have it. We have demonstrated all of these operations in the interactive shell, and we've also played around with using variables and values that are typed in interchangeably. Hi, so in this video, we're going to take a more practical look at variables. We are going to write a very simple program that calculates the volume of a cylinder. We're going to create 2 variables at the start. Those are going to be the height of the cylinder and the radius of basically the circle of the cylinder. And then we're going to create a variable that calculates volume through an expression. After that, I'm going to set you guys up with a couple of tasks to practice the skills that we're covering. Variables. Let's create 2. We're going to create height and radius. So height can be 20. Radius can be 10. So both are automatically set to integers. That's just how Python works. And now we can create the equation for volume. So volume itself is going to be a variable. And we're going to set volume to, let's see, pi r squared h. So for pi, I'm just going to use 3.14. At this stage, we could import math and use the precise pi, but that defeats the purpose of practicing basic variables. So it's going to be 3.14 r squared. So we are going to basically multiply radius times radius and multiply that by height. So now we have volume. We can print volume, and when I run this program, that's going to calculate the volume of a cylinder with height 20 and radius 10. So what I want you guys to do first is basically convert that into a compound print statement that prints out something like this. Edit something like this. Cylinder with height 20, 10 of 6.2. So just to reiterate one more time, your job is to change line 6 to basically be a compound print statement that tells the user what is going on. You can pause the video here because I'm going to go on to do this myself. So here's how we're going to do this. We're going to take portions of this and essentially convert them into strings, and then instead of these values, we're going to insert the variable names. And we're going to have to separate strings from the variable names with commas. That's the only way we can print them on the same line. Otherwise, we need to convert basically height and radius into strings in order to concatenate them on the same line. So a cylinder with height, I can almost Control C, I can copy that and paste it here. A cylinder with height, and what we're going to have here is the variable height. So a cylinder with height, hopefully it'll say 20, then comma, and radius, and then we do comma, and here we can put the radius. And finally here we can say has a volume of. Has a volume of. Here we can put volume. So let's try some arbitrary numbers. 33, 18. Okay, let's run this and see how that makes the program neater. A cylinder with height 18 and radius 33 has a volume of that. So there you have an example of how we can use variables very practically, create an equation from a new variable name and use that in a compound print statement to create a volume calculator. Now, the challenge I have for you is to go online, look up the surface area of a cylinder. The equation for that is area equals to 2 pi r height times 2 pi r squared. So I'm going to try to paste that in here. 2 pi r h, 2 pi r squared. And create a solver for this. Again, I'm going to freeze the video and give you a chance to do that before I go ahead and do this myself. So here we go. We're going to add a line right after volume to say surface area, and then we're going to basically copy and paste the statement and modify that. So surface area, compound name, we can call it surface underscore area equals to 2 pi r h. So 2 times 3.14 times radius times height. I am not really using spaces here, but I think I should to be consistent because this is going to be a long equation. So this is 2 pi r h, that's successful. And the next one is 2 pi r squared plus 2 times 3.14 radius times radius. And if you're at all concerned with things like BODMAS, basically some things happening ahead of others, it's always going to do multiplication ahead of addition. So you can just put these statements into brackets, meaning that they get processed together. It's just general good practice if you're ever. So that should calculate surface area. And in order to have a print statement, paste that one. So we can say a cylinder with height and radius that has surface area. And that should do it. So let's run this program. Height 18 has volume of, surface area of that. So that wraps it up for this video. See you in the next one.